In today's class, we are going to discuss set. Actually, set is not a strange word to us because we have been hearing set since. But today we are going to discuss the presentation of set, as in how to represent set, the set notation, that is, what are the operations under our set. Alright, set itself is just a collection of well-defined data. When we are saying something is well defined, it means that it has some certain characteristics that is differentiating it from every other data or object. Let's say now a set of SS3 students, which means that they have some certain collection, certain characteristics that is differentiating them from other classes, or we say mathematical set. Which means that with that mathematical set, they have a particular similar characteristics that is differentiating them from any other object, and that is what we call set. Maybe days of the week now to is a set, which means that they have certain characteristics that is differentiating them from every other object, and that's what we call set. Now, under the set, now we have like, let's say 4 major ways in which we always present sets or we represent sets. We have the first one, we call it words representation. In this words representation, they can give sets in form of statements, like let's say A equals to odd numbers. This one is given in words, or we should say A or B equals to days of the week. Any set given in this form, we call it given set in words or sentence form. Well, this one is known as the set bracket, while this one is the set itself. Anything you can get from this bracket is called the value of the set, or we call it element of the set. Then number 2, we can represent sets in listing form. Let's say list form. In this one, we give the value itself. Let's say this one I have it to be odd number. Odd number can be number that is not divisible by 2. We can have 2, 3. We can have 5. We can have 9. We can have 7, and so on and so forth. This one has been listed for you automatically. Then for this one, we have B, which is days of the week. We have Monday, we have Tuesday, we have Wednesday, we have Thursday, we have Friday, we have Saturday, and we have Sunday. And this is listing one, which means that all the elements given to us has been already listed. We have another one, we call it the builder notation, and that is the most used one in the set. We call it builder notation. Let's say builder. In this builder notation, you will be given rules. Let's say builder notation, you will be given rules, in which from these rules that governs them, you are the one that will form your element. Let's say we have x, and x is a member of -1, which this one is less than that x, but the x is less than or equals to, let's say, 2. Which means that this one is rules that is governing the element of the set. Anyone in this range is the value of the set. This one can be properly translated to, we have x is now a member of, remember that it's less than 1, strictly less than 1. The first number that 1, okay, -1 is less than the x. The first number that is greater than -1 is 0 itself. Then we have, most cases they will put that maybe it's an integer, where it's a member of integer. We have 0, we have 1, 2, 2 itself. The reason why 2 is included is because of this or equal to sign. The reason why this minus 1 is not included is because this one is a strict inequality, while this one is a weak inequality because of the inclusion sign of the 2 or equals to. Anyone given in this form, we call it Builder notation. At times they will be given more difficult way. Let's say we have x squared, and we now have x, which is a now from this one. I remember that the number of this range is, let's say, from 0, but this time around we are looking for x squared. Then you square it, 1 squared, and we have 2 squared, which is our value. Then from P now, it is going to be the value of x squared is 0 and 1, 4. And that is, at times it may be given in form of equation for this one, where we have, let's say, x, which is a member of x squared, equals to, let's say we have 9. And they want us to find the element of it. The element of this one is just x, which is the square root of this, equals to the square root plus or minus of these two. Then C element is just a member of plus or minus 3, which your elements can be minus 3 or plus 3. And that's what we call set builder notation. The last one is the diagram method. This one too is a very popular one, the Venn diagram. This one is the most popular diagram in this, developed by John Venn. And we have some rules too, or laws like De Morgan's law. But in the diagram form, you will be given in the diagram representation, and you are the one that will now bring out the member of the set. Like, I can draw something like this and put, let's say, A, 1, 2, 3, 4, which means that the element of A here is just 1, 2, 3, and 4. This one is a diagram form. It can be given as, let's say, A and let's say B, more than that. If they are not crossing each other, I have, let's say, 5 is here, then the element of B is 5. And that's the diagram form. Now we are done with the way in which we always present sets. Now let's talk about the types or the forms in which we always have sets. One, we have universal sets. Universal set is the set that contains all the members of the other sets, all the elements in which other members of the set are contained. Then we have types. We have finite, we have an infinite set. Under this universal, it can be given in form of finite or infinite set. If you have the final, the last member, you know all the elements in the group or in the set, we have it, we call it finite set. Let's say we have days of the week now. Days of the week, let's say x, b equals to x, which is days of the week. We know all the days of the week. All you are given like c equals to x, where x is, let's say, minus 2, less than x, and less than, let's say, 4. We know the range where we have c is the number of c is, let's say, is less than 2. Therefore, we have to be minus 1, 0, 1, 2, 3, and it's less than 4. 4 is not included, minus 2 is not included. If you have anything like this, it is finite set because we know the beginning and you know the ending. But let's not say we have D is another set, which is odd numbers. Odd numbers. All the odd numbers. You don't know all the odd numbers we have. We have it as much as we can. You understand? So, which means that this one is not finite. Or let's say all the natural number. Let's say we have E is another set which contains natural number. Natural numbers. of natural integers. We don't know the complete value of it. So if you have any of these, we call this one infinite set. But the one that you know the beginning and the end, days of the week, you know it is from Saturday to Sunday. Saturday, you have the Monday, Tuesday, Wednesday, Thursday, and the main one you have this one. Then you know the days of the week. Even you know the months of the year, because it is just 12. January, February, March, April, May, June, July, and so on. But like this one now, you don't know the all the elements, so we call it infinite set. Then we have union set. If you have set A and B, you have two sets. Let's say A and you have set B. And A has its elements. Let's say element of A is A, B, C, D. And element of B is E, A, E, I, O, U. Like this. Then the union of this set is any of the member. I mean, anything you can see from set A and you can see from set B is union of the set. And it is being denoted by this. We have A union B. We now give you any of the member. We can find A here, we can find A here. Just pick one, no repetition. Then we have B, we have C, D, we have E, I, O, U. Like this. And this is the union of the two sets. Then we have 4, interset. Intersection of set. Intersection of set. In intersection of set, it is denoted by this, and the intersection of the two sets is the member that is common, which means that you can find it in A and you can also as well find it in B. Then we call it the interset, the one that is crossing. That is, we have A is here, A is here. Then we call this one intersection of set A and B. Then we have singleton set. This singleton set is a set that contains only one element, which means that intersection of A and B here is a singleton, since it's producing one element after it has been operated. We have A is here, and nothing is common again, so therefore B is a singleton set. Then another type of set we have is empty set. Empty set is set that does not contain or that does not have any member. Let's say days of the week, which its letter starts with Z. Do you have any days of the week that its letter starts with Z? I don't think so. So therefore, any of these form is an empty set. Or you just say, let's say cow that can fly. Do you have any? No. And it is being denoted by this sign. You denote empty set by this, or you denote it by the empty bracket. And this is empty set. Or at times you can give it in form of, let's say the equation, let's say x, which x is odd number, no, let's say even number between 2 and 4. Do you have any even number between 2 and 4? No, because the number that is between 2 and 4 is 3, and 3 is not an even number. And any form of that, we call it empty set. Empty set. Empty set. So the next one we have here is, we have equal set. Equal set. We see that sets are equal. If you have set A equals to set B, what can make them to be equal is if they are having the same elements. If they are having the same elements in each set. Let's say set A is, or the same number of sets, A, B, C, D. And we have B to be D, E, C, A. It doesn't matter how it is being arranged, but provided that they are having the same elements or member of elements, we call them equal sets. Then we have equivalent set too. Equivalent set is set. Equivalent set. Let's say you have A is equivalent. We use this symbol to denote. Equivalent set is set that is having the same number. Let's say A is this, and this is 1, 2, 3, 4. Its elements. And we have B, which is A, B, C, D. 1, 2, 3, 4, A, B, C, D. Like this. They are equivalent sets because each of them can be paired one by one. They contain the same number. And we always use this sign 2 at times to denote equivalent of set. Arrow with double edge. So that's equivalent set. Another one we still have is power of set. Power of set. Power of set is the number of elements of subsets we can get from the given set. Let's say A equals to A, B, C, D. Remember that for every element, empty set is a subset. For every element, for whatsoever element given to us, we can get an empty set from it. So in this case now, power of A is denoted by this P of A. P of A. And therefore, the power of this one is number 1. We have the empty set. Then we have A, we have B, we have C, we have D, we have AB, we have BC. The power of the set A, B, C, D here is now the empty set, and I said earlier on that empty set is a subset of every set. Then we have A is a subset, B, we have C, we have D. Then we have AB, we have BC, we have CD. Then we have AC, we have AD. Then we have BD, which we can pair like that. Then we have ABC, we have BCD. Then we have CAD, and we have ABD from those sets there. Before we can now get the complete A itself, which is ABCD, which is the complete set. If you count this number here now, it should be 16. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And that's the reason why we give formula for power of set to be 2 raised to the power number of sets. 2 raised to the power number of the set. We have, how many sets do we have here? 1, 2, 3, 4. Well, for the number of set A is denoted by n of A, which is 4. Then we have power of A, which will now equals to 2 raised to the power 4, which is 16. And that's the power of set A. Let's say, for example, let's say we have A equals to, we have 1, 2, 3. Then from this one too, the power of this one is definitely giving us 2 raised to the power 3, which is the same thing as 8. That is, we have 1, we have 2 power of this set. When with the power of set, then we move to disjoint set. Disjoint set are set that does not have any intersect. Let's say this is set A, set B, and they are not having anything in common. We call them disjoint set. Disjoint set. Which means that the intersection of these two sets, A intersection B, is going to give us empty set. Or we write it this way. Nothing is going to be inside. Then we call it the disjoint set. Then complement set. Complement set is just it's always written in this form. We denote it by this prime on it, or we can denote it by this, putting small c as the power of the set, and it's just the element that is left for a particular set to become the universal set, to become the whole set. Let's take for example now the complement of A from this set here. Let's say this is the whole set. The complement of A from this set is A complement is 1 and 2, which means that if that set A can get 1 and 2, it will become the whole universal set, and that's that. It can also be written as this 1 and 2, and that's the complement of set A. Then we have super and subset. Sets that we can get from every other set. Let's say this is set A. We have 2, 3, 4, 5, 6, and we have set B given as 2, 4, and 5, like this. Therefore, B is a subset and A is superset. It is divided like this: super and subset is divided like this. We have superset, subset. This way is a subset, this way is a superset. Then A is a superset of B, while B is a subset of A, which means that A contains what B contains, even more. But we have two types of subset. Types of subset. We have one proper subset.